Welcome to Mongolia, and welcome to Mongolian National University, Mongolund Undisni. We're on top of the 7th floor of the main building of Mongolian National University, and behind me is the capital city of Ulaanbaatar. Ulaanbaatar was built over 40 years ago by the Russians, and both of the electric grid and the heating grid were built for approximately, less than 100,000 people. Today, there's over 2 million people living in the city. The buildings are heated by a central heating grid, and which very large steam pipes flow throughout the city and provide the heat. The new buildings you see going up were never planned in that heating grid, and everything basically is going to get extremely cold. You may know that Ulaanbaatar is the coldest capital in the world. We're also one of the most polluted because we rely exclusively on coal burning furnaces for the heat and for the electricity. On my right, you'll see some of the Gare districts. This is just part of this over here. The small little white tents, basically, are where many people, over 1 million people, spend their winters. It's minus 50. That's really cold. It's a beautiful day today. It's in the beginning of September here. And so let me tell you from firsthand experience, it is not always this nice. We're very grateful for the University of California and Mongolian National University to have cooperated on a high temperature solar thermal array. And this technology, we believe, will make a great impact on the country. Let's take a look. The high temperature solar thermal project you see behind me is called XCPC, or External Compound Parabolic Concentrators. The technology was developed at University of California UC Solar Project Program in Merced, California, headed up by Dr. Roland Winston, the director of that program. Thanks, Doc, you made it happen. So we got this technology about 10 months ago, brought it here with some angel funding from one of the board members of the University of California. Thank you, Mr. Robert Angle, and our chairman, Mukbat Lagvasurin, here at MNU, to help deal with some of the problems of pollution and heating in UB. Recently, we've also had help of Miss Steffi Klauder from University of Freiburg in Germany, and she's been here helping us document our findings. Steffi, can you tell us a little bit about the project?
Yeah, so these are XCPC solar collecting tubes. There's a vacuum between these two glass tubes, which makes the outside temperature irrelevant. And this generates the heat, which is then transferred and stored inside. So we can go take a look at that.
Let's go take a look.
The oil flows from the XCPC tubes through here. This is the pump that makes the system go, and then it flows into this thermal energy storage system.
The thermal energy storage system is critical to this because it is where the heat is stored at night. Basically, this technology can generate heat between 200 and 300 degrees Celsius. That heat would then be stored inside someone's home, and a separate system could then be turned on to draw the heat out into a radiator as they need the heat. We're very pleased with the results of this project. This is moving into a commercializable venture, and we're very excited about that. We're also very pleased that Mongolian National University and Mongolia can demonstrate that we can conduct high-level scientific research at a cost-effective basis that really makes an impact on people's lives. This technology, not only every single kilowatt that comes out of here means that much less coal and CO2 emissions in the air. So, if you're looking for a place to conduct your research, come to Mongolia. It might be cold, but it's a great place to do your research. Thank you so much, and we'll see you later. Bye, ta.